Hello students, in this lecture we see the integrals of the logarithmic function and the inverse trigonometric function. We know that the standard derivative of the logarithmic function, that is the derivative of log x, it is a 1 by x, and derivative of the sin inverse x, cos inverse x or tan inverse, cot inverse, sec inverse, there is a standard derivative, but there is a no standard integral of logarithmic function and the inverse trigonometric function. Okay, here the integral of log, okay, there is a standard derivative of logarithmic function, okay, that is the derivative of logarithmic function, the derivative of log x is equal to 1 by x, derivative of cos inverse x it is equal to minus 1 upon under root 1 minus x square, but there is a no standard integral of the logarithmic and inverse trigonometric function. Now, so the how to find the integrals of the logarithmic and inverse trigonometric function. Okay, logarithmic function it is a log x, and inverse trigonometric function it is a sin inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x and cosec inverse x. Here, see carefully here, to find the integrals of logarithmic function, that is log x, and it is a function of x, and inverse trigonometric function, it is a sin inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x and cosec inverse x. Okay, here we take the functions of x, okay, here, and integrate with respect to x to find the integrals of logarithmic and inverse trigonometric function. Okay, there is a no standard integral of these two functions, logarithmic and inverse trigonometric function. So we find the integrals of this function, we use the integration by parts, and integration by parts it is, see carefully, u into phi dx, it is u into integral of phi minus integral of derivative of u into integral of phi. Okay, it is a formula for the integration by part, that is u into phi. Now we find the integral of log x. Here we can find, see carefully, integral of log x, and we say we use here integration by parts, but in the integration by parts there is a product of two functions, u and v, but here only one single function. Now the method is to find the integral of logarithmic and inverse trigonometric function by using the integration by parts. We take the second function as a 1. We take the second function, that is log x into 1. Log x it is a u and 1 it is a v, and then we use the integration by parts. It is integration by parts, the formula for the u into v. Here, to find the integrals of logarithmic and inverse trigonometric function by integration by parts, taking second function as 1. See carefully. Here, to find the integrals of logarithmic and inverse trigonometric function by using the integration by parts, we can take the second function as 1. Now, for example, evaluate. Okay, here we can take the integrals of log x. Okay, evaluate integral of log x with respect to x. Therefore, solution. Here, let integral of log x with respect to x. To find the integral of logarithmic and inverse trigonometric function by using integration by parts, taking the second function as 1. Okay, now it is log x into 1 dx, and now it is u and it is v. By integration by parts we can find the integral of this function. It is u into integral of v minus derivative of u into integral of v. Okay, here integral of derivative of u into integral of v. Okay, it is a formula for the integration by parts. Okay, we can only express in the form of the formula. Now we calculate. Here log x into x minus integration of 1 by x into x. It is a derivative of log x and it is integration of 1. It is a dx. And then here we can write x into log x minus integration of 1 dx. And then x into log x minus x and plus c. It is an integral of log x. We can take also, it is a common x, log x minus 1 and plus c. It is an integral of log x and it is not a standard formula. Okay, here in the board exam there will be asked, or in the any example there is a step integration of log x. We can take integral of this function by using integration by parts like such that in the objective you only remember this x into log x minus 1. It is an integral of log x. Okay. For the objective you can remember it, but for the board exam it is a write in the step by step. It is an integral of log x. That means the integral of logarithmic function by using the integration by parts, taking second function as a 1, and same process for the inverse trigonometric function. Okay, now we can find the integrals of inverse trigonometric function. Now here we can find the integral of sine inverse x dx. Okay, see carefully. Now integral of, we can find the integral of sine inverse x dx. Now there is no formula for the standard integral of the sine inverse x. So this integral we can find by using the integration by parts, taking the second function as 1. Then sine inverse x into 1 dx. Then u into v. It is u and it is v. Sine inverse x into integral of 1 dx minus integral of derivative of sine inverse x into integral of 1 dx and this dx. See carefully. Now it is the formula of the u into v. Then sine inverse x into x integral of 1 minus integral of derivative of sine inverse x. It is a 1 upon under root 1 minus x square into x dx. Okay. Now it is x into sine inverse x minus integral of x upon under root 1 minus x square. See carefully. Here it is x upon under root 1 minus x square. X upon under root 1 minus x square. Now how to find the integral of this term? Okay, here x upon under root 1 minus x square. X upon under root 1 minus x square. It is a integral in our type, that is the linear function upon under root quadratic function. Linear function upon under root quadratic function. So here one derivative, we can adjust the derivative of quadratic function in linear function. Derivative of quadratic function, it is a minus 2x. We can adjust minus 2x in the numerator. See carefully here. We can adjust. It is minus, already minus. here we can write minus 2x, it is a derivative of quadratic function. Okay, but here only x, so we multiply by minus 1 by 2. We can write here minus 1 by 2. See carefully this. And then x into sine inverse x plus, it is a 1 by 2. See carefully, plus 1 by 2, and here integral of, okay, we can write here clearly here we can adjust the derivative, so we can write here minus 1 by 2 and into integral of minus 2x upon under root 1 minus x square dx. Okay, here derivative of 1 minus x square, it is minus 2x, but here only x, so we multiply by minus 1 by 2, it is a minus 1 by 2. Minus 1 by 2, here it is a plus 1 by 2, and here f dash of x upon under root f of x. We can again here we use the formula, that is the rule, f dash of x upon under root f of x, and it is 2 under root f of x plus c. Okay, now here it is a 2 under root f of x 1 minus x square and plus c, and now the last answer, only 2 get cancelled, we can write here last answer, x into sine inverse x plus under root of 1 minus x square plus c. Here these 2 get cancelled. See carefully, it is the last answer, that is, it is integral of sine inverse x. Okay, now we can find the integral of cos inverse x. Okay, see carefully, when we can write here cos inverse. Okay, here we can write here cos inverse. Okay, then the integral of cos inverse, taking as a second function 1, then here it is a cos inverse, here it is a cos inverse. Okay, now it is a cos inverse into x, and here derivative of cos inverse, it is a minus. Derivative of cos inverse only can take minus, and it is x square. Sorry, it is integral of 1, it is x, and now we can only replace sine inverse by cos inverse. This minus and this minus, we get plus. See carefully, this minus we get plus. Here again linear function upon quadratic function, we adjust. Okay, we adjust the 2x, or we can take this minus as it is. Here minus already, here we can take only minus, it is 2x, so we multiply by 1 by 2, and then it is cos inverse, and the last answer, it is only here it is a minus. Okay, you can find the integral of sine inverse, then the cos inverse is also same, like that tan inverse and cot inverse, because the derivative of tan inverse 1 upon under root 1 plus x, 1 upon 1 plus x square, and derivative of cot inverse minus 1 upon 1 plus x square. Derivative of sec inverse 1 upon x into under root of x square minus 1, and as the cosec inverse there is only minus. Okay, same procedure. Now we can find the integral of sine inverse and cos inverse. Now we can find the integral of tan inverse and cot inverse. Now it is an integral of tan inverse x. Okay, now we can find the integral of tan inverse x dx by taking second function as a 1. See carefully, tan inverse x into 1 dx. Now here we use the integration by parts. We can write here u into v, that is tan inverse x into integral of 1 dx minus integral of derivative of tan inverse x into integral of 1 dx, and this dx integration with respect to x, integration with respect to x. Now here it is a tan inverse x into x, this integral of 1, it is x, minus integral, see carefully, 1 upon 1 plus x square into x dx. Okay, derivative of tan inverse x, it is a 1 upon 1 plus x square, and integral of 1, it is x. Now we can integrate this function. Here x can be written x into tan inverse x, x into tan inverse x, minus, see carefully again here x upon 1 plus x square. Here it is x upon 1 plus x square. Again here linear equation upon quadratic function, linear function upon quadratic function. In the last example there is a linear function upon under root quadratic function, but here linear function upon quadratic function. Method is same. Adjust the derivative of quadratic function in linear function, and the derivative of quadratic function, it is a 2x, so we can write here 2, but here only x, then multiply by minus 2. It is adjustment. Now it is x into tan inverse x minus 1 by 2 into, here it is f dash of x upon f of x. You know, it is f dash of x upon f of x. It is log of f of x plus c, and therefore its answer is log of 1 plus x square plus c. Okay, here it is the last answer. It is the integral of tan inverse x. Okay, it is sufficient for the board exam here, or its answer tan inverse x minus, it is a 1 by 2. 1 by 2 can take in the power of this using the property of logarithm. Okay, here we use the property of logarithm, a into log b, therefore log b to the power a, and here power is a 1 by 2, and power 1 by 2 means under root. We can write log of under root 1 plus x square and plus c. Okay, it is sufficient. Okay, it is the last answer. It is the integral of tan inverse x, and same as the integral of cot inverse x. Here, when here is a cot inverse, it will be cot inverse, and here derivative of cot inverse, there will be minus 1 upon 1 plus x square, so it is a plus. Okay, that means the integral of cot inverse x, remember it is the integral of cot inverse x, it is x into cot inverse x plus 1 by 2 log of 1 plus x square. It is the integral of cot inverse x. Okay, x into cot inverse x plus 1 by 2 into log of 1 plus x square. It is integral of cot inverse x, because here there is only change, derivative of tan inverse 1 upon 1 plus x square, and derivative of cot inverse, it is a minus 1 upon 1 plus x square. So here will be written plus. Okay, here cot inverse, it is for the homework. Now we can see the integral of sec inverse and cosec inverse. Integrals of sec inverse x with respect to x. Again it is inverse trigonometric function, and to find the integral of logarithmic function or inverse trigonometric function by using integration by parts, taking the second function 1. Okay, now integral of sec inverse x into 1 dx, and therefore sec inverse x into integral of 1 dx minus integral of derivative of sec inverse x into integral of 1 dx, and it is a dx. Then sec inverse x into x minus integral of derivative of sec inverse x. Derivative of sec inverse x, it is a 1 upon x into under root of x square minus 1. Derivative of sec inverse x, x upon x into under root of x square minus 1, and into it is x dx. Okay. Integral of 1, it is x. Now this can be written, it is x into sec inverse x minus integral of x get cancelled. Here 1 upon under root x square minus 1 dx. Okay. And then last, it is x into sec inverse minus, here it is a 1 upon under root x square minus 1. Again it is a special integral, 1 upon under root x square minus a square, and its integral is log of x plus under root x square minus a square, it is a 1, and plus c. Here it is a special integral, 1 upon under root x square minus a square. Integral is log of x plus under root of x square minus a square. Here it is the integral of sec inverse x, and same it is the integral of cosec inverse x. When we can write here cosec, okay, cosec inverse, here cosec inverse x, and derivative of cosec inverse x, here you will be minus x under root x square minus 1. Okay, when it is minus, there is a plus. Okay, and here it is a plus. That means the integral of cosec inverse x, okay, remember this, integral of cosec inverse x, it is x into cosec inverse x plus log of x plus under root of x square minus 1. It is a integral of cosec inverse x. Okay, here see carefully the integral of sec inverse x, and then find the integral of cosec inverse x. Now these are the integrals of logarithmic function and inverse trigonometric function. Okay, there is no standard integral for logarithmic and inverse trigonometric function. So to find this integral, we can use the integration by parts, taking the second function as 1. Okay, here see carefully.